Hello, everybody. Thank you for joining. My name is Tunjo Dinch from Dassault Systems Germany, based close to Stuttgart. I'm industry process consultant. I will today present you engineering safety and efficiency. Thank you very much. So let's go to our first slide. Okay, sorry, it's hanging. No, okay. Okay, so what we want to talk about is detect and evaluate workers' physical constraints to prioritize automation and opportunities. You will see in this session or in this part of the presentation how we are analyzing how we are doing an ergonomic study in a plant layout environment, thanks to the integration of our solutions from plant layout to ergonomics to robotics. We are able to analyze in the same environment different topics. The second topic then will be how automation will improve the product efficiency and also to reduce the strains. Means also the quality, and you see also the performance, as I said. So in this video, first, we are looking into a PPR structure. PPR means product, process, and resource. Here you see a process planning where we define the process structure, the work orders, the sequences, how to assemble, or in this case, it's a part fabrication example, how to fabricate our parts. How do we detect and evaluate workers' physical constraints then? That means here in ergonomic workplace design, we are able to analyze these tasks. You see on each process, we are able to generate worker tasks to analyze the different behaviors of the operator. Means we see here in the panel below that the worker task needs to be defined like we see on the screen. With the right hand, we want to get something, the product, for example, we have a specific weight, and with the left hand side, the same. So we want to grab the product with two hands. But the assessment, what we see on top of the screen for the percentile, for each percentile, shows not a result. That means we need to think about the solution. We will talk about the solutions later. So that means let's go in the different definitions or in the different scenarios and see. You see also here the next thing would be, okay, we need to pick and place something. So the operator, dependent on the size, is here then has here a risk. Also the same scenario we see on the top that we have different solutions by the end. We will talk about that and we will understand how ergonomics for workplace design can help us to understand this kind of risk in a very early phase with no ergonomic skills in a very easy way and in the integrated environment like we see here, in a resource-centric environment or a process-centric environment, to use what the process engineer did, what the industrialization engineer did, and then later on to think about how we can optimize this situation. Also, raw material placement here, or GET. Same here, we see again the tooling now on the table. We see then the different percentiles of the operator are green. We will talk about this then in the session. So here we assemble the raw material. We have always the same height of the table. And we see also in a combination of the tooling, we have some risks identified by the automatic posturing engine. So EWD helps us here to analyze very early the current situation. With the left-hand side, we are holding our raw material. We have the view window. Can we see our tool? Is it something what we do in a blind mode? And what are the risks we see here on the joint angles? We should change probably the grasp access, or we should bring the object closer to the body, which is a proposal of the system. I don't need to think about it. The system can help us there in this integrated environment to analyze this very fast and very easy. So in combination with the tool, same posturing study, that means with Ergo for All, we are able to analyze, including the tooling. With the right-hand side, we are holding the tooling. With the left-hand side, we need to grab the fixture. So the raw material will be placed directly on the accessory and all be fixed there. And so we see the risk and also the time saving on the worker task on the left-hand side. And so we are able to see that this posture is very well, and there are no risks and nothing what I need to consider. And so these steps are links to each operation in our PPR environment. PPR, as I said, for product, process, and resource. Every operation has the worker tasks below, and so you're able to analyze very fastly and efficient the behavior in this station or in this cell, and think about your ergonomic situation. The video shows us then how does it work. So now we see very easy the environment. We see on the left-hand side our process structure, means the product build-up. We see the suggestion of EWD. We see the time saving to position and to bring the operator in the best posture. This is most of the time the most time-consuming activity, to posture a mannequin or to position a mannequin in the right position or in the right place in the work cell. And Ergo for All helps us to do this fully automated. With the algorithm, we are able to find the best possible posture for the operator in this cell. And here we see on the different anthropometries on the top, 550 for female and 5095 for a male, the different situations. And on each click, I see on the worker tasks what the situation looks like. In combination with the worker view, I'm able to see directly, is the operator able to see the tooling? Can I reach my product? Is it a blind assembly? These kind of things are very easy to access and to interpret. The same here, we are opening the door and closing the door, and imagine we do this frequently, the whole day, 8 hours a day, probably a whole week. And now we see that the operator cannot access the machine to position the fixture or the accessory into the machine. So we need to think about, okay, operator is 95 percentile, cannot reach the position, what to do. The same we see on these different worker tasks. So you see, by clicking easily through the tasks, I am able to analyze basically every posture which is necessary for me to have a risk-free workplace. And also here the balancing analyzed. You see here the operator is standing on the rack, taking out the accessory from the racks. And so by click, I can jump or move or see then the different percentiles and the different risks easily. So in addition, we detect and evaluate the workers' physical constraints to prioritize the automation priorities or opportunities. You see here with the cumulative assessment, we are analyzing the frequency of the activities. And here in the cumulative risk panel, we see then, according to all the tasks what we have in a specific time, what are the risks could be. And so we are not analyzing statically one by one, and we are happy that everything works. In a frequency, it could be that the risk is too high and we need to think about another solution. Okay. Here we see exactly, I just had a meeting, sorry for that. Here we see this session in the 3D Experience platform. As I said, when we look in the structure, we have here our PPR tree, product, process, and resource. And thanks to the integration, we are able to use directly from a plant layouting this manufacturing cell for ergonomic studies, for robotic studies, and other studies, including machining and additive manufacturing and other simulations. So we are able to optimize the cell according to the to our needs. We have here get and place the fixture, and immediately you see the worker tasks are below. I see easily my product built up, what is the current object, what is in the previous object. So I'm linked to my process. And easy when I look on the situation here, my operator is too tall. When I click on the risk panel, I see, okay, joint angle and the reach zone. We need to lift the table a bit. It's too low. But we see also for the male fifth and fifth percentile woman or female, it's not a problem because here we are fully in the range and there is no problem and no risk for the operator to work in this workplace. Including the vision window, we see also exactly and very easy, there is nothing which disturbs me to find my product or to assemble my product on the right place. In this situation, we are quite happy and everything is okay. So here we have in the panel we see all the different risk types. So you see which tasks are without or low risk, and also which tasks are with mid risk and so on, or high risk, or which ones we are not able to reach. And this is also something what you see easily in the process tree. When I collapse now my product buildup and my resource structure, I see easily on the symbols or on the pictures that these are the tasks what I need to redo, recalculate, and redefine dependent on what is possible, because I'm not able to say remove the racks or change the layout as I want. This is something what needs to be done in a collaborative way, and thanks to the 3D Experience platform, we can do that easy. Okay, so when we go to the next, so we see here get the raw material. So the same here, and this is basically what you saw in the video. And when I go to the task where we want to load or unload something in the machine, we see, for example, here easily the operator is not able to reach the target, and so no way to do something here. There must be another solution. We are clashing with the machine. There is a risk that the operator has some accidents here with the door and so on. So there is nothing what we can do so far. So this leads to my next point. So I just go back in my presentation. So here, what can we do? In the second step, we can replace the operator by any other resource. We see here we are targeting to have a robot simulation or a robot in our session. Thanks to the integration, we use exactly the same layout, the same cell, but we substitute our operator by a robot. We can think about how large must be the robot, which kind of offline program we need to do for the robot to do the same thing what the operator did. So now we see with the Fanuc robot here, where we did the offline programming. You see also the machining process started, and there is no risk in that sense because we reach everything. The robot can help to also increase the productivity, because here we see a parallel work between the left machine and the right machine, and so we can also think about our bottlenecks. Probably our operator was it, and so we can use the robotics solution here to improve efficiency and reduce the risk in this workplace. Exactly. Okay. So which takeaways do we have? So first, we need to target the right problems first. So by using DELMIA's virtual ergonomic assessments, we identify the high-risk tasks very early. We don't need any physical trial because we are in a virtual environment and can do different concepts and analyze them. This helps us to prioritize the safety improvements and the automation where they'll have the biggest impact. We can accelerate the smart automation, so seamless. We switch between human and robotic simulation. That means we are using our plant layout, we are placing our operator, we are calculating or analyzing easily with Ergo for all the best postures. If this is not a working solution, we are switching then to a robotic simulation in the same environment, doing the offline programming, and you saw easily we are able to simulate the new situation and analyze that we can also work simultaneously between two machines. So, and we maximize our ROI on your data, on your 3D data. So we are sorry, I cannot read it again. Repurpose existing CAD and process data to simulate, analyze, and optimize manual and automatic workflows. So we are boosting the productivity, we reduce injuries, and support smarter investment decisions.